Assalamualaikum everyone, this is Ahmed Chaudhary and welcome to Ami Physics class. Today we are going to start a new chapter, so let's not delay anymore and let's begin. I would request everyone to please write the name of the chapter and the chapter number, chapter 2.09 and electric power. So before knowing about electric power, we should know that what is electricity. Before knowing about electric power, we should know that what is electricity. Electricity is a stream of negatively charged particles called electrons flowing from negative to positive through a conductor. By this thing I mean that electricity is nothing but a bunch of electrons, a bunch of negative particles named electrons flowing from the negative terminal to the positive terminal of a conductor. Through a conductor. Electricity is a stream of negatively charged particles called electrons flowing from negative to positive terminal through a conductor. Electricity is a stream of negatively charged particles called electrons flowing from negative to positive through a conductor. By this thing I mean that electricity is nothing except a bunch of electrons or a flow of electrons from the positive terminal to the from the negative terminal to the positive terminal through a conductor. The electrons, when a bunch of electrons, or we can say that a group of electrons is flowing by a conductor or through a conductor from the negative terminal to the positive terminal of a circuit or anything, we know that thing as electricity. The flow of electricity is called current. We have learned it in the previous chapters that the flow of electricity is called current, which is measured in amperes, and the symbol of amperes is A, and the symbol of current is capital letter I. Energy is measured in joules, J. So let me write the definition of electricity at first. So as you guys are seeing that I have wrote a definition of what is electricity. Electricity is a stream of negatively charged particles. Electricity is a stream of negative charged particles or negative particles. You can write anything. Electricity is a stream of negatively charged particles or negative particles known as electrons from electrons known as electrons. There is a thing missing. There is a word missing, which is passing. Let me write it more properly. Now I have written the definition properly. Before there was a word missing. The word was passing. So now the definition is that electricity is a stream of negatively charged particles. Electricity is a stream of negatively charged particles passing from negative to positive through a conductor. I have missed another word, which is electrons. No worries that if you write electrons, that is also correct. You can directly write in this way that electricity is a stream of negatively charged particles passing from negative to positive through a conductor. This is also correct. You can also write this one. Electricity is a stream of negatively charged particles. Electricity is a stream of negatively charged particles known as electrons passing from negative to positive through a conductor. This one is also correct. And you can write this one also, that electricity is a stream of negative charged particles, electrons, negative charged particles known as electrons passing from negative to positive through a conductor. This one is also correct. Later on we have learned that the flow of electricity is called current. I am not going to write this because we have learned in the previous chapters, in the current chapter, that what is current. We know the definition of current. The flow of electricity is called current, comma. It is measured in amperes. It is measured in amperes. The symbol representing current is capital letter I and the symbol representing amperes is capital letter A. Now, energy is measured in joules. Energy is measured in joules. I would request to write these things which are written on the board. Energy is measured in joules. Joules, joules. And it's represented by the capital letter J. The flow of electricity is known as current, comma. It is measured in amperes, capital letter A. Full stop. I know that I said a few minutes ago that I won't write the second star definition, but still I wrote it because many of you may not remember this thing, so it would be a remembering class for you guys too, for you guys also. Energy is measured in joules, Joule as joules, capital in Greek bracket and write capital letter J, full stop. So joules is basically the name of the scientist who first discovered the formula of energy, or who discovered energy. There is something called energy. As energy was never invented, the terms of energy and everything we know about these things were discovered or investigated. These things were investigated. None of these things were invented. As none of these things were invented, only electricity was invented. Energy is measured in joules. Joules is the name of the scientist who discovered there is something called energy. Before that, people didn't know that there is something called energy, or maybe he discovered something else in energy. So that's why we measure energy by joules. That's why the unit of energy is joules. The flow of electricity is known as current, comma. It is measured in amperes, capital letter A, full stop. I think this is enough time for you guys to write these two simple sentences. So this thing right here now, let's see that power is measured in watts. Power is measured in watts. A power of 1 watt means energy being used at rate of 1 joule every second. A power of 1 watt means energy being used at rate of 1 joule every second. For example, a bulb of 100 watt uses 100 joule of energy in every second. For example, a bulb of 100 watt uses 100 joule of energy in every second. Now, let's give a live example. The live example is that suppose you are seeing the bulb in your room. Currently, you are seeing the bulb in your room, and it has a power mark, of 2 watts. 2 watts. It has a power mark of 2 watts or 20 watts. 20 watts. For example, it has a power mark of 20 watts. Then we have to think that it is using 20 joule every second, as 1 watt means 1 joule per second. 1 joule per second. Then 20 watt means 20 joule per second. That means that the bulb is using 20 joule of energy in every second from the mains electricity. From the main electricity, the bulb is using 20 joule of energy every second. So if the bulb is switched on for if the bulb is switched on for 2 minutes, then what will the amount of energy it will take? What will the energy it will take? Let us do this thing today. So our question was that a bulb of 20 volt is using 20 joule of energy every second. There is a bulb of 20 volts. Let's assume that a bulb of 20 volts is using 20 joule of energy every second. So if it is switched on for 2 minutes, then calculate the energy. The energy will be that first, power equals to 20 watts, which means 20 watts equals to 20 joule per second. So per second the energy is 20 joule. So in 2 minutes it is 120 seconds. So 120 seconds into 20 joules. It should be 120 seconds into 20 joules, which comes 2400 joules. So in 2 minutes a 20 watt bulb uses 2400 joule of energy from the main electricity. From the main electricity it uses 2400 joule. From the main, let me write the question. Let me write the question right now. So in exam, suppose you are in exam hall and this question comes that a bulb of 20 volt is switched on for 2 minutes. A bulb of 20 volts is switched on for 2 minutes. Calculate the amount of energy it uses from mains electricity. Calculate the amount of energy it uses from the mains electricity. Now, you will think that the teacher didn't show us any formula which is related to current, which is related to energy, time and current, etc, etc. But remember that the teacher will teach you that 1 watt equals to 1 joule of current, 1 joule of energy per second. 1 watt equals to 1 joule of energy per second. And then you are going to remember that the teacher has taught us that, or you have learned that 1 watt equals to 1 joule per second. So you will think that in 1 second, if 1 watt equals to 1 joule per second, then 20 watt equals to 20 joule per second. Then 20 joule equals to 20 watt equals to 20 joule per second. I am keeping the question. I hope that you guys have taken essays or written this question and also have written the previous things. If you didn't, please pause the video and reverse it and then take an essays or write these things. As these things are important, I am making a long chapter into a very short one and in a very detailed summary. I am basically summarizing the whole chapter in a detailed way and in a very short way for you guys to understand with some examples. I hope you guys have written the question. See here, I have showed you guys a detailed format of the answer or working of the answer of the question. The question was that a bulb of 20 volt is switched on for 2 minutes. A bulb of 20 volt is switched on for 2 minutes. Calculate the amount of energy it uses from the mains electricity. Calculate the amount of energy it uses from the mains electricity. Let me repeat the question one more time. A bulb of 20 volts was switched on for 2 minutes. A bulb of 20 volts was switched on for 2 minutes. Calculate the amount of energy it uses from the mains electricity. So what we were given, the power and the time, right? The power and the time. The power was 20 volts, and if you calculate these things, which means that the energy per second will be 20 joule per second. So that's why I wrote P equals to 20 watts, which is equals to 20 joule per second. Here by the capital letter P I mean power. The power is represented by capital letter P. Power equals to 20 watts, which is equals to 20 joules per second, and time equals to 2 minutes, which is equals to 120 seconds. I have written in this format. You don't have to give this wave. I have given this wave to separate the given information from the basic work, or from the working process I have done here. So we are given power, which is 20 watts, which is equals to 20 joule per second, and time, which is 2 minutes, which is equals to 120 seconds. So if 1 second equals to 20 joules, then 120 seconds equals to 120 into 20 joules, which is 2400 joules. This is the answer. And this process is called the unitary process, the unitary method or the unitary process. এখানে আমরা সব সময় সর্বদা সবকিছু প্রথমে 1 সেকেন্ড অথবা 1 সেন্টিমিটার অথবা 1 মিটার অথবা 1 বিন্দুতে অথবা 1 ইউনিটে আমার কত ইউনিট পাচ্ছি সেটাকে আমি সেটার সাথে কম্পেয়ার করে আমি বাকিগুলো করতেছি। For here the unit is second. For 1 second we are getting 20 joules. So for 120 seconds we are getting 120 into 20, which gives us 2400 joules of energy. You can write these things also, 2400 energy, 2400 joule, or if they say that write in a word thing or something else, the question akare diye deয় তুমি এই question akare, if they give you this thing as a in a mathematical form, then just give equals to 2400 joules and write answer till this thing is fine. And if they ask you in a question answer form, then you have to write that 20 watts equals to 20 joules per second. 20 watts equals to 20 joules per second, and time is 120 seconds. So if for 1 second 20 joules of energy is taken, or 20 joule of energy is used, so for 120 seconds 120 into 20 joules of energy, which is equals to 2400 joules of energy, is going to be used from the mains electricity. This is the mathematical form answer. Now I am going to write the question answer form answer. So as you guys are seeing that I have written this, I have given a chart and wrote that previous one was mathematical format, this one is QA question answer form answer, and given a wave there. So you don't need to write that thing. I have just written it to make you guys understand that answer, this answer is not a continued version of the previous one. This is the same, this means the same thing, but it is in detailed answer, and that is in mathematical format, and this consists of both mathematical and word format. So the bulb uses 20 joule of energy in every second from the mains electricity, full stop. The bulb uses 20 joule of, if someone doesn't understand my handwriting, I am sorry for that. I am trying to make it better, and I will try it in the future also, inshallah. So let's come to the point. The bulb uses 20 joule of energy in every second from the mains electricity, full stop. The bulb uses 20 joule of energy in every second from the mains electricity, full stop. So, comma, in 120 seconds, 120 into 20 joule, which is equals to, so in 120 seconds, 120 into 20 joule, which is equals to 2400 joules, which is equals to 2400 joules of energy is being used, which is equals to 2400 joule of energy is being used from mains electricity. The bulb uses 20 joule of energy in every second from the mains electricity, full stop. The bulb uses 20 joule of energy in every second from the mains electricity, full stop. So, comma, in 120 seconds, 120 into 20 joule, which is equals to 2400 joule of energy is being used from the mains electricity. So, comma, in 120 seconds. So, comma, in 120 seconds, give bracket, open bracket, 120 into 20, close bracket, joule, capital letter J, which is equals to 2400, capital letter J, which is 2400 joule of energy is being used from mains electricity, M-A-I-N-S, mains electricity, E-L-E-C-T-R-I-C-I-T-Y, electricity, full stop. I hope you guys have written both the answers and the question also. If you didn't, please take an essay of this thing. Now let's us hear some examples of this thing. That some examples. For example, a bulb is getting. There is a formula related to this thing. There is a formula by which we can calculate power, voltage and current. Power equals to voltage into current. Power equals to voltage into current. Power equals to voltage into current. This is the formula by which the power of any electrical component or anything, of anything is calculated. Of any electrical component, the power is calculated by this formula, that power is equals to voltage into current. Let us write the formula. So this is the formula by which the power or voltage or current is calculated of any electrical appliance. Power equals to voltage into current. The second formula is current equals to power by voltage. The third formula is voltage equals to power by current. You just need to remember if you remember the first one, you can make, or you can use the second and the third formula automatically, as these are just simple algebra. The thing we are going to be asked, if we are asked for voltage, we are going to subject voltage, and which will lead us to dividing current by power. Dividing power by current. We're dividing power by current. And if we are asked for current, we are simply dividing power by voltage. If we are asked for current, we are simply dividing power by voltage. That's all. This is all you need to know. Now, quickly let us listen to some examples. So, for example, a bulb is getting 3 ampere of current from a 12 volt battery. So, if we are asked to find out the power, we will use the formula power equals to current into voltage. Let me repeat the example one more time. For example, a bulb is getting 3 ampere of current from a 12 volt battery. Remember these two things. We are given what? The amount of current and the amount of voltage. And if these two things are given to us, we can be sure that we are going to be asked to find the power of the object, or to find the power of this thing. So the power, for finding the power, we are simply going to use the first formula, power equals to voltage into current. The voltage was given 12 volt and the current was given 3 ampere. So 12 into 3, which is 36 watts. 36 watt. Another example, a television uses 150 watts of current. 150 watts of current. 150 watts of 17 ampere current. Another example is that if a television uses 150 watt of a television uses 150 watts. Another example is that a television uses 150 watts of a current and 17 ampere of current. Another example is that a television uses 150 watts and 17 ampere of current. So for finding the amount of current, we are simply going to use we are given the current and the amount of power. So we are simply going to use the formula number 3, which is equals to voltage equals to power by current. So voltage equals to power by current, which gives us 150 watt by 17 ampere, which ultimately leads us to a huge answer. But if we take up to 4 decimal places, the answer comes 0.8824 volts. This is taken up to 4 decimal places. This is taken up to 4 decimal places. So, Alhamdulillah, we are done with chapter 2.09, electric power. So, new video is going to be released after January 18, as I have some work and I have some exams upcoming in this upcoming January. So, let's hope we are going to see the new video very soon. So, Assalamu alaikum everyone.